Alright, new project. I recently built a simple crystal radio set from a kit put out by United Nuclear, and I mentioned in the video I made about that I had tried making crystal sets a few times when I was a kid and a young adult and didn't really have much luck with them. The results were so poor that I just sort of gave up the whole idea. But then when I got that United Nuclear kit and got actually pretty good results from it, it sort of reinvigorated me into delving into crystal radios a little bit more. And I decided, if nothing else, I would like to have an example of Heathkit's one and only crystal radio, which I have on order, have not yet received from eBay, and also just a typical basic crystal radio set, a manufactured item, not a homebrew. And this is one that I bought on eBay from a seller in Pennsylvania. It says manufactured by C.J. Morrison, Newark, New Jersey. But when I open it, it has the National Radio Institute A1 receiver, the Junior, listed, and there's a lot of pictures, well, maybe not a lot, but a number of pictures online, various radio museums and so on, that list the NRI A1 receiver as a kit that was put out and also manufactured pretty closely to the kit by a number of manufacturers. And there's ones that look essentially identical to this, except instead of the Morrison badge they have a National Radio Institute badge. And there's a difference, and some of them say standard there, some say something else, although it's hard to read in the low resolution pictures that people often put up online. But ones that clearly do not say Junior in that position, and they seem to be just the same as this, except right about here there's an additional knob. And although I haven't found any concrete information on this, some collectors I've talked to online have said that they don't know about the Junior version, but that the standard version definitely has a tuning capacitor in this location, and otherwise still has what is essentially a selector switch for tuning the coil in steps, and then the usual terminals for the headphones or earphones, and the ground and antenna, and the cat's whisker for the crystal detector, and a storage place for the headphones or earphones or whatever. So I decided I'm going to clean this up for display purposes. I will also try to get it working, although it's in kind of rough condition electrically. I've removed the screws here so I can lift this out. And you can see that, yes, it has a coil wound around a cardboard form, and it is a tapped coil, so it's a bunch of separate windings with the ends twisted together and then brought out as pairs of wires to all these different selector points. So you can have essentially a coil with a different number of windings. Then there's a lead that comes off the end of it and goes to what's probably the ground connection for both the antenna and the one side of the earphones, and then a wire coming from over there, which is no doubt coming from one side of the cat's whisker detector, and that's going to here, so that would be the other side of the earphones. And then over here is the terminal, which is presumably the antenna, and it's going to the other side of the crystal and around here, and it goes to the common of the selector switch for the winding, the coil winding. So obviously a very simple, as simple as it can be, except for the complexity of the multi-tapped coil. It should be possible to get it working. Now, you may wonder, why isn't there a capacitor in here? And while I'm not an expert on the fine points of crystal receivers, I know you need to have a capacitance in parallel with the coil to get any kind of selectivity out of it. But this being the junior version and coming out probably in the 1920s, as I believe this set dates from that period, as do most original crystal sets really, the airwaves were not, the broadcast band was not flooded with stations back then, and you maybe didn't care so much on this stripped down junior version if you had really good selectivity or not. You know, this was probably pushing closer to a pretty broad selectivity or low selectivity circuit, which you could get working, but it wouldn't be great. But it saves the cost of the variable capacitor. On the other hand, if you have a proper antenna, you know, your wire antenna that's hanging between two trees outside and so on, you have to look at the antenna physics, and without going into it too much, if you have the wire and it's getting close to the length of the wave, the radio wave, then it doesn't have much capacitance. But if you start using a fractional length antenna, maybe a quarter of the wavelength of the signal you're trying to tune in, then kind of all of a sudden the antenna develops its own capacitance that's substantial enough to be used in a crystal set like this as the tuning capacitor, part of the resonant circuit or the tank circuit, without actually having to have a capacitor in here. So it's not imperative that I get this working, but I do want to clean it up, so that'll be the first part of the focus of this video. I've already wrung out the circuit as I just did in the video because it's so simple, but I need to wring out the coil and make sure there's no broken connections. Everything looks intact, but I need to make sure that it's still okay. The coil doesn't sit on a pair of pillow blocks, it just sort of floats there, and I believe this is original, although I couldn't corroborate that with anybody. But it has just a piece of cloth cord nailed to each end. On this end it's torn free, and that just goes through the coil, and the coil just sort of hangs suspended from the cord, and there's enough flex in the fine wires for the coil itself that it can move around. I am not able to establish 100% whether that's the original design on this or if it's some kludge that somebody implemented later, but I don't see any evidence of there being any mounting blocks for the coil, so I think that is original. Again, this end is busted off, so I'm going to get a new piece of cord, put it in there, and nail it down. The nails are still here. There's the one where it tore off, so that should be pretty simple to implement that repair. And I'm going to go through and again check continuity and make sure that there's no bad connections there. There are only 3 screws to hold the control panel, if you will, in. 2 of them go on this spacer, 1 of them goes on this little block, and those are here, but they're pretty nasty looking, and so I'm not sure yet if I'm going to reuse those or get some new screws that are similar. And they're kind of stripped out of the wood anyway, so I would need to fill those holes and then re-drill them and put the screws into them. The hinges look like they're in pretty good shape. They're not even loose. There's a crack on the lid, but it doesn't feel particularly loose. I'm probably going to wet some super glue into there and not really fill it, because I'm not going to refinish this. I'm just going to clean up the existing finish. I want it to look old, not, you know, it's hardwood. I could probably clean it up and make it look really beautiful, but that's not the look I'm going for on it. So I'm going to pry off this nameplate so I can clean up the wood around there. On the advice of some other old crystal radio set collectors, I kicked around different ways of finishing and presenting this wooden case, and every last one of them said either strip it down, refinish it with modern stains and varnishes, and the other probably 60% of them said no, never do that, that's considered bad form. you want to get yourself some boiled linseed oil as a carrier and some sort of very fine abrasive rated for wood polishing. And they recommended rotten stone, which is just like powdered limestone. I imagine any number of things would work. This was sold on Amazon as rotten stone, but when I got the actual product, it didn't match the description, other than that it's a super fine wood abrasive. It doesn't say what the ingredients are. I don't think it's under this label either, but you know, whether it's the powdered limestone or some equivalent thing, I don't know. But they recommended, you know, getting any lint-free cloth and getting some of the abrasive in some of the boiled linseed oil and just rubbing it down on the wood and leaving it at that. I want to see if I can get this instruction card out of there so I can do some repairs on it and clean the wood up without getting linseed oil soaked into the paper. So I don't think it's held down by very much, and I've made this just little sheet metal tool to try to gently pry it out of there. We'll see how that goes. Yeah, that lifted out pretty easily. I'm not sure it was actually supposed to be glued in there. It's like somebody put the glue in later, because this is the flip side of the instructions, and you can't take it out if it's glued in. So I think I will just put it in there. Let's see, so this one actually acknowledges C.J. Morrison as the manufacturer, and except for where it peeled off here, is it E? Alt-Hay? I don't know what that says. Oh no, that may be an X. Looks like it's an X, so what would that be? I gotta put my thinking on cap on and see what that might be, but it does say manufactured by C.J. Morrison of Newark, New Jersey, and here it clarifies the binding post at the back of the box to the aerial, next binding post to ground, the two other binding posts to the headphones. So I'm going to first get some anti-stickum on here and try to clean that out. I just used some of my Tech Spray label and adhesive remover with cut up pieces of t-shirt and was able to get all the gunk out. Somebody had sprayed this liberally with adhesive and it was real tacky and thick, and it took quite a lot of elbow grease and applications of the solvent, but it came off and it doesn't seem to have hurt the wood or its finished at all. And I similarly rubbed down the areas where there was adhesive. It looks like I missed a couple of spots I'm going to have to do again. You can tell by the glare where it still is. There's a little bit down here too. But this stuff evaporates, so it's discoloring the cardboard now, but it won't once it dries. I've pried off the name tag and the latch hardware. Alright, so I have some of this yellow nylon cord. It's about the same diameter as the original cord, actually slightly larger in diameter, but not as dense as the original. So I pulled the little tacks out, I stuck them through the cord, and then pressed them in with the end of a large pliers into new holes adjacent to the old holes, and then I sealed the ends of the cord with super glue. Normally I would heat that up, but with it being this close to all these other things, I didn't want to get the flame in there, so it definitely will hold the coil just sort of suspended there like it was originally, but yet there's enough clearance to get underneath it if you have to inspect the solder joints on the switch. So I think that's good. All of these pieces have been rubbed down with a combination of the linseed oil and the wood polishing abrasive, and allowed to wait about 10 minutes, then rub down with a clean cloth, get any excess oil off, and now I have to just let it dry. I also put some super glue before doing the wood treatment along the crack there, which wasn't really loose. It was just, you know, I think it was being held down by the glue along this seam, but I still tried to stabilize it with a little super glue, rubbed it into the crack, wiped off the excess. I have the hinges hardware and their little nails soaking in some white vinegar just to see if I can loosen up some of the corrosion on there, but I'm not going to buff them. I'm going to leave them more or less with their current patina. Now I have to figure out what to do with this nameplate. It almost seems to have some sort of varnish over it. It's probably original. I don't really want to remove that. I'll probably just work it over with a little isopropyl and see what happens. So I've done what repairs I can to the torn up instruction card. The pieces that had come off I've glued back on with tiny amounts of super glue, but it still shows. It's not like it's a hidden seam, and it wouldn't be regardless of what I used. Some of them I did from the rear, some I did from the front, and there's some pieces that are just flat out missing, but at least it's stabilized. I'm thinking that this is probably good enough just to put back in there, but because it has sort of a permanent curve to it and the paper is quite brittle, I'm thinking that I may scan it and then reproduce it as double-sided on cardboard and put that in there, and then keep this one in my file folder documentation package for the radio. I have to think about that. Meanwhile, I've soaked in vinegar and scrubbed with a toothbrush these little fittings. It's definitely got some deep corrosion on there, which didn't come off with that treatment. I don't want to really start sanding or wire brushing these. I don't think I could ever get it looking good. It's probably better just to leave it the way it is. And the nameplate, I did get some gunk off of it. It's a little cleaner, but it still, you know, has some corrosion and so on. But it's an old piece of kit, so that's okay. Alright, I've got the box back together, hardware back on. I filled the screw holes here. They were stripped out with epoxy and re-drilled them, pilot holes for threading the screws back into. Came out looking better than it did originally. It's still the same color, but it has a little less of a dusty look to it. Anyway, certainly an improvement. Okay, I reconstructed the instruction card from the original. I had it glued together enough to tolerate scanning, and then I cleaned it up and tried to just reprint a fresh copy of it, but the colors came off so much that it looked pinkish or something else. So I reduced it to just black and white, and then reprinted it on some cardstock with a sort of a period patina to it. This is probably pretty close to the way this looked originally. So this will be the one that I put in the radio, and then I'll put the other one in my file cabinet along with other documentation about the radio. Alright, this is cleaned up. Like I'd said before, I'm not going to replace the paint on here. I'm going to leave that for its period appropriate look, but I have cleaned up. I polished the contacts on there, polished up the binding posts, I verified there is still a crystal in the holder there. And like I'd shown before, I've replaced the support cord for the coil. I've cleaned up the back of it. Isopropyl alcohol on Q-tips, wiping up all the dust and stuff. I have probed this out, and it seems like all connections are good. The only active component on here, it's not even an active component, the only thing that isn't just a connection is the coil. And I connected up my digital inductance meter to it and went through all the switch positions and got ascending values that seemed about right. So I think the coil is in good condition, as is the switch as are the switch contacts. So again, this should work now. And here's the schematic. Have the antenna, then the antenna binding post, the ground and the ground binding post, and the two binding posts for the headphones. I leave off the details here for the cat's whisker and just showed a diode. But you come in from the antenna, you go to the wiper of the variable inductor variable coil, and then the common side of that goes to ground. Now we have to think about the hidden capacitor, which is formed between the antenna and ground when we have an antenna that's substantially shorter than the wavelength of the broadcasted signal we're trying to tune. So that forms sort of a, well, it's not a virtual capacitor, it's a real capacitance, but it's not a capacitor. And that would be again from here to here, so essentially across the coil. And that gives us our tank or resonance circuit. And then across that whole thing is the rectifier or detector diode, or the cat's whisker doing the same thing, and the high impedance headphones. So a classic crystal radio set. The inductances I got range from 125 microhenries up to 412 microhenries, and those are about the values I would have expected for a AM broadcast band crystal set. They're certainly in line with the coil values I've seen on some other crystal sets. There's how my replacement instruction card fit in there. It just fits in there by friction. I trimmed it down so it just went in barely without buckling the paper. Alright, I have my antenna hooked up to the antenna terminal. Ground is going to the ground prong on an AC outlet. My piezo earphones are hooked up to those, and I wasn't able to get any success with the cat's whisker, so I just hooked up a set of test leads to a 1N34A germanium diode, and it's working. It's not nearly as strong as the United Nuclear one that I built and have a video on, but let me see if I can capture any of it. And my old Western Electric 509W cans also get a usable signal, but I don't find it's actually any better than the earphone. I don't know if I'll be able to pick any of it up here. Alright, I've added a set of powered computer speakers, just connected across the piezo I'm actually going to try it without the piezo in there, just go directly.
Toward the back end of his prime, so you see what's out there, and you do what you do to think there's a deal to be done.
I've got a couple channels going at the same time there.
And I feel like that might have been the case for a guy like Bruce Hall, for example. We know was available. He talked about potentially getting out of New York. Seemed like a reasonable spot for Bruce Hall, but now he's stuck there because nobody actually traded for him.
Well, nobody offers the Jets what they would have taken in order to their asset. And what they have is a guy on an expiring contract. They show no inclination to sign a new deal, but if he leaves as a free agent, that goes into this whole calculation of compensatory draft. That didn't happen for the next draft. If you trade a player on an expiring contract, and what would you expect to get as a compensatory draft if that player leaves as a free agent? And that's one reason some of these trades get done. The team is having to take on. Even though they traded for the best players, look at what they picked up. 20 first-round picks, a second-round pick, and a couple of players. That's not fire sale, that's retail. 7-win, 2-2, and 23 for years for their key players. And there are only a handful of players who are truly untradeable in the NFL. Sauce Gardner and Quentin Williams weren't, and now they've got some important pieces they can use to build that team's future.
Food at every
Oh, there's a strong one.
At 125 to the Mediterranean Sea on today. Mike, if you're dreaming of a high-end escape that delivers on every level, this is it. Visit Cap St. George's Hotel and Resort. Experience life. CapStGeorges.com. John, it took
Yesterday from Eagles GM Howie Roseman. He did
Arm
a
from-
conference after the trade deadline came and went. He was asked about
Team.
Jay Brown.
Oh,
The way
maybe
he
that's
explained it wasn't.
Is it $33.87?
He's not a guy that you ever trade under any circumstances. It was, hey, you know, we're in the business of keeping good players, and we're trying to build a super. If you would.
Cities, religious faiths that voted for Mamdani, just enough to get him over the finish line, 50.4%. Although it was Cuomo with around 42%, so I wouldn't call it close, but he just got over the majority line. The cover of the New Yorker is, let's see, this was November 17th. So the next issue coming out of the New Yorker shows the open doors of a subway car, and the drawing is of that Rainbow Coalition, if you will. It's an old man. There's a person who looks like he's Jewish.
So I'm getting several stations, 2 or 3 pretty strong and a few listenable. Anyway, it's certainly working with the germanium diode, not with the cat's whisker. I made up this little 1N34A germanium diode with short alligator clip leads on the ends. So if I want to fire up this old crystal radio again, all I need to do is take this out of hiding and clip it across the front side points, if you will, of the cat's whisker assembly. So let's look at the circuit of the radio. This is a very minimalistic set here. So its only component is the rectifier for the AM detector and the tuning coil. Those are the only parts. Everything else is terminals and wiring. So we know that a basic crystal radio has the antenna, it has a coil, it has a capacitor in parallel with the coil, it has the detector, a rectifier, and it has some means of listening to the resulting signal, usually a earphone or a set of In this instance, there is no discrete capacitor in the circuit. However, radios like this are designed with the assumption in mind that you're not going to have a really long antenna, so you're going to end up with an antenna that's, a fraction of the length of the wavelength of the radio signal you're trying to receive. And in that situation, the antenna to ground circuit, if you will, the connection between the antenna and ground, forms sort of a virtual capacitance. Well, it is a capacitance, even though there's no physical component you can hold in your hand. It still has capacitance, and because it's from the antenna to ground, it's in parallel with the coil, which is also from the antenna to ground. So that's where you get the capacitance from. And then, of course, you've got the resonance of the capacitance and the coil, the inductance of the coil, that turns the whole thing into a notch filter, where it's, or more like a band pass filter, an anti-notch filter. So it's highly attenuating any radio frequency which is not at the selected resonance of the RC circuit. And it passes without attenuation the radio frequency signals that are close to the resonance of the RC circuit. And hopefully there's not more than one station within that band that's being passed, so you only hear one station at a time. Although with a very crude set like this, and with crowded airwaves that we have nowadays, unlike back in the 20s when a radio like this would have come out, the poor selectivity of a circuit like this makes itself known pretty quickly when you get 2 or 3 stations playing at once and you can't adjust it better to get rid of the extraneous ones. But after that, everything else is the same as a normal crystal radio, coming right off the top of the tank circuit or the resonance circuit. You've got the detector, which can be a cat's whisker going into a semiconductor crystal. It can be a germanium diode. It could be a number of things. But in this particular radio, it was a cat's whisker going into a crystal, which has disappeared. I thought there was still a little bit of it in there, and I thought it might be enough to work, but I couldn't get it working. So for the demonstration in this video, I just clipped on with a set of test leads, 1N34A germanium diode, and that did the trick. It's modern diodes replacing crude homemade diodes. And then I used various things to detect the resulting audio signal across the headphone jacks. I used a crystal or piezo earphone. I used a magnetic high impedance headphone. I connected it up to the input of a set of powered speakers. All of those worked. And that's really all there is to it. Oh, I should add that I measured the inductance of the coil. I don't know the capacitance, but you could probably figure it out working backwards from the known frequency that you're receiving, if you can figure out which one it is. But if you select the tap on the coil, and I should have gone into that more, in this particular radio, instead of having a variable, constantly variable coil by dragging a wiper along the edge of the coil where the insulation's been scraped off the wiring, here it's done in steps. So there's actually a bunch of smaller coils wrapped right next to each other on the coil form, which is an air core. It doesn't have any ferrous material in it. It's just a coil wound in air. So you go in steps here. The most inductance you can get is about 412 microhenries. Then 368, 350, 301, 270, 243, 220, 187, 158, and 125 microhenries. is the smallest value, and then the remainder of it is in the part of the coil which you can't tap into. I got these old headphones. They're supposed to be high impedance headphones. I'll check that. I got these from a resale shop in Merritt Island, Florida, near the Space Center, and they seem to be more or less period appropriate, but I'm not absolutely sure. Let's see here. Are they dated? Well, they are dated. So, made in the USA, Western Electric, patent in the USA, July of 1918. Does it say 500 watts? That's probably a model number, not a power rating. And it says exactly the same thing on the other side. The headbands are in pretty good condition. It's just canvas with the metal spring steel inside. I think these are the original cords. They have a strain relief that's knotted around a screw that, or something that protrudes, or a little tab, so that allows flexibility here without it actually pulling on the conducting wires. And then they're spliced right about here where the left and right side wires come in, and then at the other end you just got the strain relief cord hanging in space with the two conductors in fork lugs, crimped and soldered, or at least soldered. Yeah, they're not, well, they're crimped around the insulation, then they're soldered electrically. It looks more like 509W and then 1100 or something. That does look like a model number. Well, these are probably still high impedance to some extent, but they are not piezoelectric. They are coils, but they don't move a, they're not like a moving coil type of situation. It's a stationary coil, and then there's just a metal diaphragm. I don't know what it's made out of. Well, it's ferrous material, so it's probably just really thin steel. Definitely sticks strongly to a magnet. So, yeah. They are dynamic headphones. They are not piezoelectric, but there might still be enough coil resistance in them to merit a high impedance. The wires end in little ferrules, or whatever they'd be called. I imagine they're soldered in there, and that allows them to be easily removed. Stick them in there and turn those two screws to tighten them down. Measuring with an ohm meter directly across the screw terminals, I'm getting just under 1100 ohms. So that's apparently what that 1100 means here. Doesn't say ohms, but apparently that's what it is. Maybe it's just a coincidence. The other one measures a little over 1100. Putting a diaphragm back in place. The bodies are brass or some other non-ferric material, and the diaphragms just slide back on. They're varnished on the back side, and I found out that even a little isopropyl alcohol wants to take the varnish off, so don't make that mistake twice. Gonna get the diaphragm centered back on there. And then it's just a matter of screwing these Bakelite ear cups back on. These are all cleaned up now. I'm suspecting that with an impedance of 1,000 approximately ohms each, in parallel that's going to be, you know, around 500 ohms. I might be able to just drive these with the regular headphone output of something. Well, they do work. The higher impedance side has a slightly lower volume, but not very much. Obviously, they're running as a mono set of headphones. I'm just driving them from one channel of the headphone output of a CD player. But they're working, but I'm sure that the impedance is too low to use on a crystal set. So not able to use this for the intended purpose. They just make good decoration around my lab, I think. But I'm not sure that these are actually wired in parallel. They may be wired in series. So I'm going to detach one lead of each one and then probe it out and see what I get. Well, actually that was sort of dumb. I don't actually need to do that. I can just clip my ohm meter onto the end of the leads and see what it is. So these are reading out at about 22, almost 2300 ohms. So they're definitely wired in series. Now it's interesting to note that these are symmetrical devices here, and the wires have a blue stripe and a white stripe. I can't see the blue stripes on this side anymore, but the white stripes on this side. So I'm assuming this is the blue stripe. I've temporarily marked it B, so it looks like they're wired in series but opposing. So coming in with a white on the left, going out on the right with a blue, and then making its way back to here. But again, maybe those aren't really kept contiguous in here, so that may be misleading. Well, I took the diaphragms off again and verified that the way it's wired is the blue striped lead from the cable goes to the one that's marked 2. There's actually a little 2 down there for orientation. Kind of hard to see. And then it's daisy chained, but it leaves with this is a blue, this is a white, and then it goes to a white, and then it exits with a blue here, but it ends up being white on the other end. So obviously they haven't just paralleled these here, they're in series, and apparently it's a completely different cable in order to change from a blue to a white going through this junction here. However exactly they're doing it, but apparently it's being done right here. So anyway, it's wired conventionally for a 2-cup but monaural headphone. They're wired in series and with the same polarity.